Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on August 3rd, 2025, so just a couple of days ago. This paper introduces a new model that improves retrieval performance by over 10% on a key benchmark for long document understanding. The paper is titled SitEmb 1.5, Improved Context-Aware Dense Retrieval for Semantic Association and Long Story Comprehension. And as we'll see, this new training approach has some really interesting implications. The authors tackle a common problem in Retrieval-Augmented Generation, where splitting long documents into small chunks loses vital context. And they propose a new way to embed these chunks while keeping that surrounding context in mind. Alright, so to really drive this point home, the authors show this set of charts. They took two existing models, Gina v3 and Embed v2, and tested them on a book plot retrieval task. What you're seeing is that as the chunk size gets bigger, going from 512 up to 2560, the retrieval performance, or recall, actually goes down. You can see the trend clearly with the red arrows. This is the core problem. Simply making chunks bigger to capture more context isn't working. This table then details what happens when you try a different approach. Instead of one big chunk, you give the model a small chunk plus its surrounding text, what the authors call situated context. For existing models, this is a disaster. You can see their performance plummets when given this situated context, with many scores dropping significantly. In stark contrast, the author's own SitEmb models at the bottom actually get a performance boost from the exact same information, showing they are specifically designed to leverage it effectively. Building on that, the authors then test how robust their new models are. Specifically, they check if performance changes when you vary the amount of surrounding text, what they call the situated context length. This table shows the results for both the SitEmb v1 and the larger SitEmb v1.5 models. As you can see by looking down the columns, the recall scores are incredibly stable. Performance doesn't really drop off, even with very different context window sizes, which is a really positive sign for practical applications. Okay, so beyond pure retrieval, the authors wanted to see how this translates to downstream tasks, like long story question answering. This table shows exactly that, across several different benchmarks. We're looking at scores like F1 and accuracy, which just measure how correct the model's answers are. The key takeaway is in the third data row, where the SitEmb v1.5 model consistently outperforms the standard QN3 model. Look at the detective QA column, for instance. There's a really nice jump in accuracy. This proves the point. Better context-aware retrieval leads to better story comprehension. Alright, so digging into the experimental details a bit. The authors are very transparent about their setup. This figure shows the specific query format they used for some of the baseline models, like E5 Mistral and GTE Quinn 2. You can see they don't just feed in the user's query. They add a one-sentence instruction at the top, telling the model exactly what to do. This is a common practice for instruction-tuned models, and showing it helps ensure the comparisons we've been looking at are fair and transparent. And in that same vein of transparency, this next figure shows the specific prompt used for the Embed v2 model. You can see it is quite explicit. It tells the model its job is to embed a passage for retrieval, but critically, it must use the surrounding context to enhance that embedding. This structure, with distinct fields for the context and the target passage, is how the model is guided to create the context-aware or situated embeddings that this whole approach is built on. So to wrap up, this paper makes a really compelling case. Instead of just making text chunks bigger, which we saw doesn't work, their SitEmb models show that explicitly situating small chunks within their broader context is a much more powerful approach for retrieval and story comprehension. That's it for this episode of